let's just dive right in, because today we are unpacking the absolutely fascinating story and mind of Sabrina Pasterski. Get this, at just 32 years old, she is already recognized as one of the top theoretical physicists in the entire world. I mean, we're talking about a mind that caught the attention of legends like Stephen Hawking. Naturally, the media couldn't resist slapping a massive, heavy label on her, eager to call her the new Einstein. But here's the hook. She completely rejects that title. No way, she doesn't want it. So why? Well, to understand this reluctant genius, we really have to look at how her incredibly unique journey actually began. And it all starts with a seriously unusual Christmas list. Sabrina once said, "I was 9 years old when I asked for a flying broom for Christmas. Instead, the family got a plane." She was just a kid reading Harry Potter, and like literally any 9-year-old, she wanted to fly around on a magical broom. Her family's response? They went out and bought an actual, real-life airplane. She notes it was surprisingly cheaper than a car, but obviously a far more interesting alternative, right? It's just such a hilarious and memorable story, and it instantly humanizes her. It completely shatters that whole stereotype we tend to have of the isolated, brooding genius sitting alone in a dark room. Instead, her genius was born right up there in the sky. Section 1. From a broom to an airplane. So think about it. When your family buys you a plane instead of a toy broom, it completely shapes your reality. Her progression from there is just astounding. At age 9, her dad enrolls her in flying lessons at the local airport, dropping her right into this vibrant community of builders and pilots. Fast forward to age 14, she doesn't just fly planes now, she actually builds her own. Yeah, at 14. She realized super early on that with the right approach, a person can build literally anything. And it's exactly that hands-on, sky-high ambition that propelled her all the way to age 32, where she now sits as a top theoretical physicist. So how exactly did this wild background shape her brain? Well, she applies a strictly practical lens to, frankly, everything. You see, Sabrina was raised by a bunch of engineers. Her dad, specifically, is both an electrical engineer and a lawyer. Talk about a combo. He really instilled in her this idea that theoretical physics isn't always practical enough. Because of him, she learned to view physics through the perspective of a company that would actually use her labor. She wants real-world application. She isn't just staring blankly at whiteboards all day. She's actively looking for utility. Actually, originally, Sabrina dreamt of a career in aerospace. But she pretty quickly hit a wall. She said, "When I enroll in aerospace, everyone just writes drone codes. They don't build planes at all." Remember, she had already built a plane with her bare hands at 14. So she walks into aerospace engineering fully expecting to get her hands dirty, building the future of human flight, and finds out it's mostly just coding for drones behind a screen. She just didn't think that was cool enough. And honestly, that is the fascinating reason she pivoted entirely away from aerospace and threw herself into theoretical physics instead. Section 2. Women in the exact sciences. Now, changing fields definitely didn't mean leaving challenges behind. Today, women make up a stark 10 to 15% of theoretical physics, just 10 to 15%. Sabrina transitioned into heavily male-dominated spheres, and she's been super open about the realities and the hurdles there. But here's what's actually kind of surprising. Sabrina notes that her experience back in aerospace engineering was honestly much tougher. She recalls visiting aerospace companies as a kid and seeing very few women who weren't working as secretaries. And while people were usually eager to help her, it often came with this underlying bias that girls needed to be treated differently than boys. As she entered academia, there was this massive industry-wide push to bring more women into science. On one hand, she found this highly motivating. Institutions wanted to showcase successful women and their achievements, and obviously the intentions there were good. But in a highly competitive field made up of maybe a few thousand people who basically determine your fate, being heavily singled out can create some unintended resentment. Sabrina points out that it can breed bitterness among peers, making people look at you as if you're receiving accolades or accomplishments that you didn't actually earn. And that complex dynamic right there is exactly why she flat out rejects the new Einstein label. She said, "I never accepted it as true. You start to wonder if they talk to you because you're a great physicist or just popular." She wants to be a famous, top-tier physicist, kind of like an Olympian in her field. But she wants that recognition to be strictly for the quality of her hard work and her actual concrete discoveries. Absolutely not, because she's just a media darling or a flashy headline. Section 3. Two large-scale theories. Okay, to truly understand the actual work that earned her this immense respect, we have to look at physics on two fundamentally different scales. And don't worry, we're going to demystify her scientific work without getting bogged down in all the heavy jargon. On one side of the ring, you have quantum physics, which deals with the incredibly, mind-bogglingly tiny, think atoms and subatomic particles. On the other side, you have the theory of relativity, dealing with the incredibly massive, gravity, planets, huge black holes. Right now, these are basically two completely separate languages that just don't perfectly talk to each other. But if there is one grand theory that explains everything in our universe, it absolutely has to cover both. And that brings us to her life's work, quantum gravity. Sabrina describes her work really simply. She sees it as building a mathematical model that essentially acts as a filter. So imagine taking all these wildly complex theories from both quantum physics and relativity and passing them through this filter to sort and align them. The ultimate goal? To create one single, unified understanding of our world. She is quite literally trying to organize the rules of the universe. How wild is that? Section 4. The future and startup thinking. Now, despite working on what is arguably the ultimate theoretical puzzle, her highly practical upbringing deeply influences her vision for the future. There's a really stark contrast between her current academic environment and her ideal one. She's noted a pretty massive flaw in academia, and it's isolation. In theoretical physics, you're often working completely alone, and academics generally don't know how to sell or apply their knowledge to the real world. Compare that with startup teamwork. In a startup, you have these dynamic teams of people working together to achieve incredible things and actually implementing scientific achievements to create real-world change. In fact, she says if she had to change careers today, she'd head straight into the startup world without looking back. Because she values practical applications so much, she actually makes a very bold claim. When asked what will change the world in the near future, she doesn't point to theoretical science. Nope. She points to practical engineering, specifically large language models, or AI. She firmly believes that these engineering breakthroughs possess the greatest immediate potential to transform our world. It's just a fascinating perspective coming from a theoretical physicist, right? She's openly acknowledging that short-term, massive global impact is going to come from the engineers building tools, rather than the scientists writing formulas. So for anyone aspiring to make an impact, Sabrina's advice is highly actionable. First off, don't be afraid to try new things. If you don't fit in, change your environment. Find what holds real value to you. And lastly, listen to valid criticism, because often critics actually have a point, and you can use that feedback to improve your chosen path. It's an incredibly grounded, practical philosophy from someone whose head is supposedly stuck up in the theoretical cloud. Sabrina Pasterski didn't settle for coding drones. She didn't settle for the academic status quo, and she certainly doesn't settle for the flashy labels the media tries to put on her. She looked at her surroundings, and if she didn't fit, she built her own path, sometimes literally building an airplane to do it. So I want to leave you with a question derived directly from her own philosophy. If you don't feel like you fit in, will you change your environment? Think about what you are building today, and I'll catch you in the next explainer.